Thank you everybody for sharing openly all the information. This is my first speech in English, so I'm Scottish. So excuse me for my English, probably nobody will understand nothing, but I will try to expose the things that we are doing in Hydra Space. We are located in Madrid, and this is the team who forms our company. We are a small team of young engineers, and during science 2000 year, we started to work in this technology, in PocketQube technology, and since then we have been able to launch 13 satellites to the space. It's an incredible quantity of satellites, an incredible quantity of hours invested in this technology, and I want to present a question that I have regarding to this satellite. Nowadays, we have 4 satellites working in the space, not working, 2 working very well. It's a communication satellite, open for everybody because it's a pen pipe transponder that can be used freely. And probably during the next month, the OTB will launch us 2 more satellites, and we hope that everything will working properly. What happened in the future is something that we need to see, but an interesting experience that we have last year was that we flew a PocketQube screwed in the second stage of Ariane 6. In the picture you can see here 4 points to screw our small satellite in the second part of the Ariane 6. I think that something happened in the second part and is flying, nowadays is flying around us, but we have no power. The second stage was not expected to be flying during long time. For that reason, this unit is flying, but switch it off. Here is the technology that we are developing. It's a PocketQube of 1 P5 size. It's around 50 by 85 millimeters length, and everything inside the satellite is developed by us. It's a big effort, but it's the only way to introduce in this small size a high functionality that permits a small company like us to win money. That is the thing that we try to do in our company. All the elements are, as I explained before, all the elements are developed in-house, but the most interesting part is the software-defined radio that permits us to implement new protocols, new waveforms to develop different services. Nowadays, we are focused in Internet of Things communications, but we expected to introduce this technology for maritime communications, and as explained before, is operating as a pen pipe transponder for amateur radio use. So any of you can buy a small walkie-talkie and try to talk with people of other continents with our satellite. The satellite is done using commercial parts. Somebody was asking about the solar cells. Here we are using monocrystalline silicon cells. They work very, very well. And we can provide the telemetry that we download from this satellite just to see what is the loss of performance along the time. But probably the solar cells are, the life of the solar cells will be longer than the life of the satellite. For that reason, I think it's a good idea to use these silicon cells. But we are also using 3-junction gallium solar cells just to provide a space-grade solution. All the critical parts are designed at transistor levels just to survive to latch-up events, and the circuits are designed carefully to avoid single pointer failures. But obviously, we have no redundant parts. We have some redundant parts. For example, each solar panel has their own MPPT, but if we lose, for example, the receiver, obviously we will lose the satellite, at least the reception part. Here is a picture of the diagram of the system, and the satellite is built with around 800 different elements. More or less, we take around 6 months between build the satellite and get in orbit. Is more or less the launch window the build and launch window that we have. We have been launching every 6 months since 3 years ago, more or less. But the question, that's the technology, but the question is, can we make money with this device? As you know, the technology must be useful for the society. Sounds a bit stupid, but it's true. For example, I love the technology of the 50s, but nowadays nobody is using it because obviously now nobody can win money because nobody can use that technology in a useful way. For that reason, we need to find something really useful to do with these satellites. Obviously, there are as an educational element, it's useful, but it's difficult for a company like us to survive with this market. For that reason, we are facing different markets and tested different markets. But I think that the problem, I forgot to mention that the problem is the figures of merit. The cost divided by the volume is very bad, and the cost divided by the average orbital power is also very bad. For that reason, it takes a lot of effort to survive as a small company selling services around PocketQube technology. But I think the key idea is to think not only in one single satellite, is in a constellation. Is in the way that this technology, I think that sounds quite interesting. The small size permits not to fly cheaply to the space. The small size permits to send, in an economical way, to send to the space a constellation. Why a constellation? Because with a constellation you can reduce the service latency, the time that the information is generated at some point and arrives to the ground station, and the revisit time, the time that takes to visit again and again the same point of interest. I think is the key value of the PocketQube technology. With this idea in mind, we tested different markets. We are in the Internet of Things, as explained before, to send information from sensors to satellites, and to provide communications between satellite and ships. But we are also working in in-orbit demonstration of devices, system operations. In order to get to arrive to these markets, we developed these ideas, the high level of integration between the electronics that controls the satellite and the electronics that develop the service. We integrated both elements with the same parts in order to reduce the size of the satellite, and we are testing non-trivial operational concepts. I think it is another key idea in PocketQube technology. It's not up at the beginning. Maybe you don't think about this, but it's important. One thing is the power that you are able to generate from the sun. In our case, it's around 400 milliwatts average orbital power. But you need to waste more energy in order to have some useful service. For that reason, you need to manage the energy along the orbit. you need to implement algorithms, ideas to use the energy stored in the battery in the useful places. It's another key idea in PocketQube technology. This is a service that we are providing to different companies. It's the way that we are getting revenue from companies is in orbit testing for fast TRL cleaning. Other peoples like us, they are trying to increase the level of the TRL. As you know, in order to get trust from the final users, you need to provide devices, systems with high TRL. And using this technology, the PocketQube, you can introduce key elements of your system in these small satellites and send to the space in order to increase the reliability of your system. And not only the reliability of the system is the way to get more experience in the team and to get confidence in the project. As I write here, once you have reached orbit, the project value and the credibility soars. This is an important thing for the investors, for the people working in the company, etc. As use cases, we flow in the past 3D printed structures, for example, graphene, different science materials, photonic devices, laser, fiber optics, and we flow in the past also to different thrusters from ENI and another company from the States. These are examples of different elements. Here is a device from SmartEar, a company that presents us also presentations. We develop, we are testing communication systems from other companies. Other companies will flow devices developed by different universities, etc. It's the kind of things that we are flying with our small PocketQubes. And the technology that we are developing, we are facing these markets, the agriculture market, the maritime market, the farming market, in order to connect different devices, animals or sensors to our satellites. We are developing satellites, but in fact we are a communications company designing low bitrate communications between sensors and satellites. And we are exploiting different ways of this technology, the story and forward. We get the information from one point of the orbit, and we download in the ground station in another point. This kind of communications is the story and forward. One technology that we develop in-house regarding the communication, this is the common technology that is used in ground. Different user terminals, in this case are buoys floating in the sea, sends randomly information to some satellite flying over the sensor. The satellite moves from one point and one point, and when it's over the ground station, downloads the information. Because we have no confirmation of that the packet information arrives to the satellite, the user terminal repeats again and again and again the information. But this faces a problem that the sensor needs a big battery to store energy to repeat and again the information. If you are able, when the user terminal sends the information to the satellite, if you are able to send back acknowledge to the user terminal stops to repeat the information and waits to the following pass to send new information. This clears the channel, and other sensors can use this free time to send information. This permits to scale to a big number of user terminals. And this is the technology in communication that we are developing using PocketQube satellites. We develop satellites to give service to other people, and we use these satellites to develop our communications technology. In the future, as commented, probably we will fly as a hosted payload and a bigger satellite, because we think slowly is a service that mega constellation will provide us. And that's all. Some question?